I start? This is the aluminum boat challenge. Have you, anybody done this activity before? You have? Okay. Well, you got an advantage. The key for this, I believe, is to only give one sheet per group. And then they move on to the second sheet. They're supposed to learn from their first challenge to improve their boat design. And so I've cut these the same size. They're 30 by 30 centimeters. And so each group will get a sheet. You're to make a boat, and you're trying to get as many pennies that'll go in the boat before it sinks. I know a lot about pennies. There's two really important things for this activity to work well, I believe. Now it depends. Are you going to recycle copper or not recycle copper? That's important to know. If we pretend it's just a challenge and it's nothing about recycling copper, you'll be better putting pre-1981 pennies in your boat. Does anybody know why? I'm saying it backwards. Actually, you'll be better to do post-1981 pennies. And you gave me the reason that the pre-1981s have more copper. So if you actually try this, I don't think I have a scale, but if you weigh 10 pre-1981 and 10 post-1981, you'll find about a 2-gram difference in those pennies. So you can get more pennies in your boat post-1981 because it's like 90% zinc, and which is a lighter metal than copper. A second thing is when you go from boat design 1 to boat design 2, can you think of anything that might be a factor as far as how many pennies can go in your boat? Yeah, all those are true, but a lot of times students forget to do something to their pennies. They use their same pennies.
You gotta dry them off.
Dry them off. Water has weight. So it would behoove you to dry them off. I've got called up on here the worksheet you're to use. Let me show you. Here. Somewhere buried in this. Hold on. Find it. Right here. So here's one of the things I do with these project-based learning is we have a vignette for everyone. This one is the aluminum boat challenge. Let me see if I can find the vignette here. A little bit of background information. This is on Blackboard for you to fill out. But step 3. You have recently been asked to design a barge for the Copper Recycling Corporation. The purpose of the barge will be to transport pennies down the Mississippi River for copper reclamation without sinking. You will have 2 design opportunities to sell your barge to CRC. Success has the potential of your company receiving a multi-million-dollar contract. And so, on down, name your barge company. Then there is some data in here that you need to fill out. The number of pennies held, the mass of your pennies, the volume of your boat, and then the density. Now, how in the world would you figure out the volume of your boat? That's one way. Probably a messy way to do that, but that is one way. Another way would be if you made your boat into a box, length times width times height. If you make your boat into a canoe, you got a problem. So but that is 2 ways. Just try to do the math way and then do the science way. There's actually a third way that's easy, really easy. Does anybody know the density of water? It's a nice number. It's 1 gram per milliliter. 1 gram per milliliter is the density of water. So you put 200 pennies in your boat and it sinks. When you put that 200th penny in there, the point where the boat sinks is going to be a mass, which is, I think each penny will say is 2.5 grams, so that's 500 grams. The point where the boat sinks is very close to the density of water. So what's the volume going to be? Point where the boat sinks is very, very close to the density of water. Right when you put that penny in, your boat sinks. If your mass is 500 grams, what's the volume going to be? They're all looking at you, Paige.
Please stop. Please stop.
It's a 1-to-1 ratio.
500.
500 milliliters.
That is correct.
Oh my gosh, I was going to say that, but I didn't.
So whatever your weight is that sinks the boat is going to be the volume. Very close. A little bit off, but very, very close. A lot closer than if you measure it. It's going to be a lot closer. So you need to answer that. Now, you do have some extra credit questions that come in here. You're welcome to answer those. You're welcome to go to the article, which is a reading assignment that goes with this. You can answer questions in there. There's a lot of questions in that article. But I really, as far as getting your 2 points, you need to stop after you do boat design 2. And we'll see which group got the most pennies to go in their boat. That's the challenge, is to make a boat that'll hold the most pennies. Any questions about what you need to do?
So
All right.
count 200 pennies individually? Like
Well, I just threw out that number. I don't know how many pennies your boat will hold. I have no idea how many pennies. We've actually had some groups get pretty close, maybe more than that. I mean, it is possible. You just gotta know how to make the right kind of boat.
Well, do you,
What if we get all
Don't make the
pennies, we run
Titanic.
out of pennies before boat sinks?
Yeah, I hope not. I told my graduate student to put a whole bunch in a cup. But if it happens, we'll have to do something, I guess. We'll have to see if we can come up with more pennies. Y'all could donate to the Dr. Summerall Need of Pennies Fund. Yes.
how to make the boat?
That's your job.
You said a box.
No, I didn't say that.
You didn't say a box?
I said that's one way you do it to calculate the volume.
Oh, okay, but how?
You can make the boat however you want to.
Okay.
That's the challenge.
Okay.
Any more questions? All right, so I've got 2 water tubs. I hope that one doesn't leak. She may have got one that leaks. So you can turn it off now.